In recent years, there has been a growing tendency amongst architects and developers to construct tall, prestige blocks of flats and offices, often with low-level buildings at the base. In order to provide the best compromise for natural lighting, these blocks are normally constructed with their long axes running approximately north-south. The result is that even on comparatively calm days, there are unpleasant high winds at ground level, often in unexpected directions. From one group of tall buildings to another. This time at Leicester University, where considerable research and effort is going into investigating the problems associated with the aerodynamic effects of tall buildings. Here, at the Department of Engineering in the Fluid Dynamics section, a low-speed wind tunnel is available to study exactly what happens when these conditions prevail. Various techniques of flow visualization are employed, and for the purposes of this demonstration, cotton strands show the airflow in a visual form. Note how an apparently steady airflow seems to be slower at ground level than at the top of the building. Also, notice how turbulence is associated with obstructions, such as these tall buildings. With the cotton strands arranged in a horizontal fashion, turbulence behind the buildings becomes increasingly apparent. Flow patterns can be seen in better detail when a clear plastic model is placed in a water stream. Hydrogen bubbles are used as a flow tracer and are produced at a fine platinum wire by electrolysis. Different attitudes of the model produce differing flow patterns. By replacing the two-building model for a single slab-sided block, flow at the base can be seen to form a regular pattern, namely a vortex. Let us now look at a plan form of the obstruction. The effect is to slow down the advancing air so that the axis of the vortex becomes increasingly curved. The upper layers of the air are traveling faster than at ground level, and upon meeting an obstruction, some of the upper layers are deflected downwards, causing a vortex upon meeting the slower ground layers. A side view shows the downward action of the vortex in profile. it can be clearly seen that there is an urgent need for more research in this field, especially when one considers the problems associated with a complex precinct like this one. The need for close cooperation between technologists and architects, as well as extended research, is vital if we are to avoid going back to the drawing board.